Hey guys, today we're going to be talking about the quadratic formula. Now, we're just going to be talking about the quadratic formula in terms of rational solutions. So, if you have some questions about irrational solutions in the quadratic formula or non-real solutions, you want to check out another video. But here we are going to talk about rational solutions, meaning polynomials that can be factored through traditional methods. So let's say we have this polynomial here, 3x minus 11x, 3x squared minus 11x plus 10 equals 0. That's the important part. Never forget, it has to equal 0, no matter what. And we have the quadratic formula here. Negative b plus or minus the square root of b squared minus 4ac all over 2a. I know, that's simple, right? In reality, it's actually not too complicated. It looks crazy complicated, I agree. But there's 3 variables there, all 3 of which we know the values of. So let's identify those. We need to know A, B, and C. Now we're familiar with the fact that A, B, and C are the coefficients to our terms in a polynomial. So A is going to be 3, B is going to be negative 11, and C is going to be 10. Well, one step down. We identified our A, B, and C. Now we want to substitute those or write them in our quadratic formula in place of those variables. So negative B, well, negative 11. What do you think would happen there? Yeah, those 2 negatives cancel out and make a positive, right? So we have positive 11, even though I just went to write that negative sign, plus or minus, that's a weird mathematical symbol, isn't it? We're going to talk about what that does here in just a bit, times the square root of b squared, or yet again, negative 11 squared, minus 4 times a, 3 times c, 10. And this is all over 2a. So 2 times 3. So we did our substituting. We've put a, b, and c into this expression, into this formula. And we want to go ahead and solve. I'm going to go ahead and write my steps right over here. So step 1 was substitute a, b, and c. Step 2 is going to be, let's do all of our multiplication. We have a lot of instances of multiplication, or exponents here, which, let's be honest, is just multiplication too. Let's do all of that. Right here we see negative 11 squared. Well, negative 11 squared is, 121. Positive. It's very easy to make that mistake of writing that as a negative. You always want to be careful about that, especially because your calculator might say negative when you type that in. We have these multiplying. What I personally like to do is keep this negative here and take positive 4 times 3 times 10. That is not what you have to do. You could multiply it by negative 4. You just wouldn't leave the minus sign there in that case. What I'm saying is be sure you're not accidentally using this minus sign twice. So 4 times 3 is 12, and 12 times 10 is 120. So I'm going to erase what we have here and write 120 in its spot. And then we have 2 times 3. 2 times 3 gives us 6. All right, we've simplified a lot of the stuff here. The next thing we want to do is what I like to call solve the square root. Maybe you should say simplify. Maybe you like that word better. Maybe it's more mathematically correct, but I think solve. So the square root of 121 minus 120. And the first thing we want to do, of course, is go ahead and subtract those numbers. So we have 121 minus 120, or just 1. And then we ask ourselves, can we take the square root of that? Well, in this case, absolutely. The square root of 1 is 1. Now, it's not always going to work out quite that easily. You might have a 49 or maybe a 36, possibly even a 64. But we've taken this equation and worked it down to a lot less numbers, right? We started with this crazy stuff, and now we're down to just 3 numbers. I do want to mention about the square root as well. If you are doing a problem with rational answers, a problem that can be traditionally factored, you will always get a perfect square there. Now, I'm not saying every polynomial ever. There are polynomials that'll get you not a perfect square, or there's going to be polynomials that'll get you negative square roots. Those are situations for another video. That is possible, but with the problems like we're doing, we're always going to get a perfect square. So this is where things get interesting. I'm going to clean this up a little bit, write it as just one little equation. 11 plus or minus 1 over 6. So this is where the plus or minus comes into play. What we're actually going to do is we are going to split this expression into 2 parts. One that is adding, another that is subtracting. Because that's what it means. It's quite literally plus or minus. That there's going to be one situation where you use it as plus, one situation where you use it as a minus sign. So I'm going to do that. I'm going to say split the expression and solve. So I'm going to have an 11 plus 1 over 6 and an 11 minus 1 over 6. Now 11 plus 1 is going to give me 12, and 12 over 6, we know that simplifies to just be 2. There's one of our answers. That's one of our values of x that would make this polynomial equal 0. In our second situation, we have 11 minus 1, or 10, over 6. That's not going to work out quite as nicely, but we can reduce it as a fraction, which we want to do, and get 5 over 3. That is our other value of x that would make this equation equal 0. We could have found these methods through graphing, or we could have found these answers through the method of graphing, and we could have found these answers through the method of factoring. This is just another option on a way to solve polynomials. So if this isn't necessarily your way, check out the video I have up on graphing. Check out the video I have up on factoring polynomials. But if you like this, you like that equation, and you think it's pretty straightforward, easy to use, then by all means, this is a great way and a very successful way to solve these. If you have any questions about this or have any specific problems you want me to go over, feel free to drop them in the comments below. Otherwise, thanks for watching, guys, and I'll see you next time.